For most of our time looking up, space has seemed pretty quiet, almost peaceful, right? We've got our stable star, this big, mostly empty solar system.
Yeah, it feels benign from here.
Exactly. But then December 27th, 2004, something hits Earth. A blast of energy from deep space.
Okay.
So powerful it actually squished our planet's magnetic field. And almost nobody noticed.
Went under the radar.
Completely.
Yeah.
But here's the scary part. Scientists figured out if whatever sent that blast had been just a bit closer,
Uh-oh.
poof, atmosphere gone, planet sterilized, instantly.
Wow. Not a supernova, you said?
No, not a supernova, not a black hole. Felt more like, I don't know, a warning shot from something weirder, something astronomers are calling like the universe's deadliest beacon. So what was it?
Well, that's what we're diving into today. We're talking about magnetars.
Magnetars.
Yeah, these are hands down the most magnetic objects we know of anywhere in the universe. But to really get what a magnetar is, you first need the background on neutron stars.
Right, the basics.
So picture a really massive star running out of fuel. It goes supernova, big explosion.
Right.
But the core collapses inwards, crushing itself down into something maybe the size of like Manhattan.
Dang neat. But heavy, right?
Heavier than our sun, all that mass in a city-sized ball. It's unbelievably dense. You can't really picture it.
Mind-boggling density.
Exactly. But sometimes, very rarely, something extra violent happens during that collapse. The brand new neutron star is born spinning ridiculously fast.
How fast are we talking?
Maybe hundreds of times a second. And this super fast spin acts like a kind of cosmic generator, a dynamo.
Okay.
It twists and amps up the star's magnetic field to just insane levels that honestly stretch what we thought was possible in physics.
And that creates the magnetar.
That's how you get a magnetar, yeah. They're truly extreme and pretty mysterious things.
Okay, let's try and grasp that magnetic field strength. You said most magnetic. How strong?
The numbers are wild. We're talking 1,000 trillion times stronger than Earth's magnetic field.
1,000 trillion. That's just a number. It doesn't even register. Can you paint a picture?
Well, all right, think about this. Our research suggests if you took a magnetar and put it where our moon is, forget compasses going crazy.
Yeah.
It would literally pull the iron atoms right out of your bloodstream. The moon's distance.
Oh, wait.
Oh, yeah. And every credit card, every hard drive on the planet, instantly wiped, blank. It would even mess with the atoms in your body, warp them. That's the kind of force we're dealing with.
Okay, so proximity is obviously bad.
Yeah.
Very bad. But you mentioned the real danger isn't just being near one, it's their anger. What's that about?
Right, the anger. That refers to something called starquakes.
Starquakes.
Yeah.
Like earthquakes, but on a star.
Exactly. Because that magnetic field is so intense, the magnetar's solid crust is under enormous constant stress. Imagine tectonic plates, but twisted by forces billions of times stronger than anything on Earth.
Okay, I'm following.
So sometimes that crust just can't take it anymore. It cracks, it shifts. That's a starquake.
And that releases energy.
A lot of energy, which brings us right back to that 2004 event. There's a magnetar, SGR 180620, about 50,000 light years away.
50,000 light years. Pretty far.
Very far. In the constellation Sagitta, it had a major starquake. And for just 1/10 of a second, it blasted out more energy than our sun produces in like 250,000 years.
In a 1/10 of a second.
In a 1/10 of a second. And that blast, traveling for 50,000 years, still hit us.
Hit Earth. How?
It slammed into our ionosphere, that upper layer of the atmosphere, messed up radio signals. Every X-ray satellite we had saw it plain as day. A direct physical effect from 50,000 light years away.
That's incredible.
And here's the chilling calculation people did afterwards. If that same magnetar, SGR 180620, had been just, say, 10 light years away, that same 1/10 of a second blast would likely have triggered a mass extinction event. On par with the dinosaurs, it would have shredded our ozone layer completely.
Wow, from 10 light years. That's practically our backyard, cosmically speaking.
Relatively speaking, yes.
So the big takeaway here isn't just space is big and powerful. It's how connected things can be, even across these like impossible distances.
Absolutely. It shifts our perspective on cosmic hazards.
Yeah, magnetars really serve as this stark reminder, don't they? That the universe isn't always this quiet, predictable place. There are these, I don't know, unseen monsters out there.
Cosmic powerhouses.
Right. It's lighthouses, but Their beams aren't meant to guide ships. They're just pure energy, potentially destructive. It really makes you think. What other forces, maybe things we haven't even discovered yet, might be out there in the deep dark, subtly influencing our world or, just waiting to make themselves known?